You're listening to Data Center Therapy. Please take a number, and an engineer will be right with you.
Hey, hello everyone, and welcome back to yet another episode of Data Center Therapy, a podcast from Voxley Consulting that talks all things IT with a healthy dose of empathy. I am your host, Matt Yette, and alongside me once again is my co-host, Mr. Matt Cozzolino. Matt, how are you?
Hello, I'm wonderful. How are you?
I'm great, and I'm even greater.
More good.
Because we've got our network savant, everything, and consulting manager, Mack Nethkin, joining us today. Mack, how are you?
Good. Thanks for having me today.
Yeah, it's really good to have you on. It's been, we've had you on a couple times already, but it's been a while since the last one. The first virtual one, too. Our previous two have been in person.
That's correct.
You guys are way closer now. Yeah.
It would take you maybe about 20 minutes. You're about 20 minutes away, probably, on a good day. Yeah. Well, I've got a very messy office right now, but it's prepped for studio work, too, Max. So we can, I could have you sit on the guest couch over there. I can sit over here in my little... Yeah, we can do that. It's more than 6 feet apart, too, so, So check all the boxes. So what we're going to talk about today and why we brought Mac on is we wanted to talk about, Mr. Cozzolino is going to chime in quite a bit here as well.
Totally.
But SD-WAN, also known as software-defined WAN.
We're software defining everything these days.
Right. Coming off the NSXT, software-defined networking, now we're software-defining wide area networks, and more aptly known, like Mac says, is BYOC.
Yeah.
Bring your own circuit. Go into that a little bit.
Yeah, what's that? What do you mean? What's that mean?
So we'll start out with what is SD-WAN, right? So I like to jokingly say it's BYOC, bring your own circuit, because SD-WAN does not have connectivity. It's a management platform for the connectivity. The wide area networks on networks are almost always the choke point of the infrastructure. They're almost always the hardest to work with. It's usually the most expensive part of the network. So what problem does SD-WAN solve? So management, ease of deployment, WAN performance, cloud app enablement, and security at a high level. We'll go reach in some more detail. So in general with SD-WAN, looking at the wide area network, if you've got a lot of branch offices and you want to acquire or bring up new branch offices, maybe through acquisitions or as you're growing, usually bringing that branch office is always rather complicated and a lengthy process. SD-WAN simplifies that.
And why is that? Like, what about bringing up a new office is complicated that SD-WAN is solving? Is it just circuit provisioning?
Circuit provisioning, as well as getting all the routing and firewall rules and everything else created, as well as the type of circuit connectivity also matters too. With SD-WAN, we go from caring about is this internet or is this internet to it's just a circuit. It just connects. We don't care.
Okay.
But I noticed also a lot of people, they want to, when they look to the cloud, not even a branch office, but the cloud as a point, they might have an MPLS network, they might have point-to-point links, and then they have a 50 meg internet circuit for internet traffic.
Mm-hmm.
Then they want to take all 3,000 mailboxes and put them up in the cloud. Well, that bandwidth now shifts from a LAN to a WAN link, and now you've got a 50 meg bottleneck. And something like SD-WAN lets you bring something a little more wide bandwidth-wise and fold it into the design a little easier, I think, right?
Yeah, cloud app enablement is probably the biggest driver, I would say, for SD-WAN. If you think about this, historically networks have been very centralized and distributed. So you have your branch offices that would connect to your WAN, called MPLS, and then that would connect to the data center. The data center has an internet connection, and then we do a VPN from the data center to the cloud, AWS or Azure, and then we move our workloads to the cloud. We've now put the workloads as far away from the users in the branch office as possible, right?
Mm-hmm.
So we're adding latency, we're adding more bottlenecks, we're adding more things to break in the middle.
More failure points, right?
Why can't we just plug the cloud into the MPLS network? Then you go branch office to MPLS to the cloud. That's what SD-WAN is.
Kind of like a mesh.
But you can't bring these cloud apps on into MPLS because they're connected to the internet that's what SD-WAN does. Is it says, okay, go to less expensive internet circuits. Is usually how SD-WAN's deployed, although it can also work with MPLS too. So you can have MPLS and internet connections.
Oh, it's a circuit. It's a link, right?
It's a link, right?
Yeah.
To be able to so that everything can connect back and forth. Then you can bring on your AWS and your Azure right into your SD-WAN fabric.
So I think the confusing bit to a lot of people about SD-WAN is that there's this, it's not necessarily a magical difference, is it? Right? Fundamentally at the core, it's still leveraging our VPN tunnels and that. It's just a unified management point. Is that what you'd say the benefit is?
Yes. Definitely unified management simplifies a lot of the routing. All of that happens in like a black box. You don't worry about it. Every SD-WAN provider has a routing protocol of sorts that they're running, and most of them are proprietary to some degree. They'll peer with the infrastructure using conventional protocols, OSPF and BGP, but inside the SD-WAN fabric, that's like what happens in MPLS. We're like, that's a service provider's problem. They figure all that stuff out. SD-WAN is
it's a layer you don't care about.
Kind of the same thing, right? I send my data. If the packet needs to go to the branch, it goes that way, and it goes into the SD-WAN fabric. How it gets to the other end is the magic the SD-WAN fabric automates, and it's more than just routing. It's also compression. It's data checking to make sure the data gets to the other end correctly. If you have multiple links, it'll use all the links that are available. You can customize it and say, these are my important apps, so these go first, and they go on the primary link, and send all my lesser important traffic on this less expensive circuit, potentially. So there's some traffic shaping you can do, some quality of service you can do through it. And all of that is done through a management dashboard of sorts, usually.
Do you draw a distinction between like the different types of SD-WAN? Because you can group some stuff. So I'm thinking like the Meraki's of the world are doing, here's a couple of links, and the CloudGenix, the Veloclouds are doing more, right? So like what's the difference between those two styles of SD-WAN?
So I look at it as there's like an on-prem and there's a cloud-based approach to SD-WAN. So on the on-prem approach, that's going to be like, Viptela I know you can do on-prem, or your conventional, like pick on Cisco's IWAN product, which really wasn't a product back in the day. It was a bunch of technologies that had already existed bundled together that would give you a site-to-site VPN, using their dynamic multi-point VPN, which creates the mesh so all the branches can talk to each other and can talk to the two data centers. Then you would do some performance-based routing, so you can say, this path is better than that path, but all that had to be configured manually. Platforms out were very hard to work with, very complicated, right? Hard to understand. The cloud-based approach is really where I think SD-WAN shines, and that's effectively where you get a white box. And they say, take this white box, and it's got an inside interface and a bunch of outside interfaces. Plug all your circuits in the outside, plug your internal network to the inside, and it picks up the traffic and puts it into the SD-WAN fabric and gets it to where it needs to go. And then there's a cloud-based management portal that you would administer it. Meraki's is a unique one because I think they kind of live in both camps, because Meraki follows more of the on-prem model where you have their firewalls, but there's a cloud dashboard to manage it to make it easier.
Well, so from a cloud standpoint, if I can jump in, I'm about the cloud point. Is this something that would be an alternative to standing up a VPN tunnel? So you do a VPN gateway in the cloud and then have a VPN device on site to establish that tunnel. Would this be in addition to or instead of, perhaps?
I'm not trying to understand the question. I know there's arguments made with SD-WAN that you could do security gateways. Some of the providers will have a security gateway in the cloud where you may not need an internet edge anymore. You could leverage the SD-WAN fabric for your inbound on internet traffic and stuff.
That's kind of like, do I get a what is Azure Express Route or whatever from my data center into my Azure or my AWS environment, right? Do I buy that 100 meg dedicated link from my cloud environment to my on-prem, or do I stand up a virtual appliance and let the SD-WAN fabric make it magic?
Yeah, because something about pinching everything through a VPN tunnel at high bandwidth, that can get very expensive from a firewall standpoint. If you're going to be able to encrypt a gig a second, right, you're talking about a big boy.
That somewhere, right?
Right, exactly. So you can't, given that routing, you can simply make that a private path into the cloud also, right? With SD-WAN. I think Azure or something could just be another point on that mesh, more or less.
Mm-hmm.
Yeah. And I remember when SD-WAN was coming out of the gate, a few years ago, I remember them extolling the virtues of locality to cloud services, where the cloud can be anywhere, but almost kind of a CDN style routing where, depending on where you're coming from, you could be at the same company, two sides of the country, and you're going to actually hit different access points based on locality, or take different paths in SD-WAN. I think you alluded to it, Mac. You can kind of weight routes based on where they are and prioritize there. And that seemed pretty cool too.
Yeah, absolutely.
So that's one of the ones. It's not quite SD-WAN. One of the ones that I've seen and played with a little bit is the Prisma Access, where it's that software-defined client endpoint VPN, which is kind of what you're talking about. I hit my vpn.company.com, and I happen to be in New York, so I get a local to New York endpoint to connect to. And if I hit vpn.company.com in Seattle, I get a local to Seattle endpoint to connect to. Right?
Anycast, right? Anycast DNS.
Yeah, I think that's what some of that is. It's more the I can stand up that endpoint, right? I can build my SD-WAN provider anywhere. I can put out multiple of them and have you connect to this device no matter where you are, and there's multiple of them you can connect to.
So all of this sounds like I'm able to buy a bunch of cheap circuits instead of my really expensive point-to-point prioritized private links. Mac, am I saving money with this?
Potentially. So when you look at, is SD-WAN right for you? Cost savings, I frequently hear, that's why people want to go to SD-WAN, and generally
because MPLS is expensive, right?
Right. It's
air quotes. Yeah.
It's turn off your expensive MPLS circuits, but also note those MPLS circuits have SLAs with the carriers for repair, where the internet, the less expensive internet circuits are going to have a lesser SLA. But if you have multiple of the cheaper internet circuits, then it's probably a wash. But you're going to take the savings of the more expensive MPLS circuits you turn off to turn on cheaper internet circuits. That delta, you're going to have to reinvest into the SD-WAN service, right? Because there's a hardware component to SD-WAN, which is the white boxes, effectively, that pick up the traffic and move it into the SD-WAN fabric. That actually makes deployment and stuff much easier, actually. It's not like, I got to go replace all my firewalls and deal with the routing. You just put the box in line like a bump on a wire, and then you do the configuration, and that migrates you to SD-WAN fairly seamlessly. But cost savings is usually, if you save money, it would be a little bit, but it's not going to be like cutting your IT budget by any large amount. I wouldn't expect that.
More like shifting dollars from connectivity to the actual
So you say, well, if
hardware.
if I'm not saving a lot of money, why would I do it? Well, you're getting the ease of management, right? So you're spending less time focusing on the WAN. You're also able to connect to your cloud apps easier and faster. You can turn up branch offices more easily, turn them down much easier. And
this is something Kaz and I were talking about
also be some
on that last episode.
On traffic too.
Yeah, we were talking about that in the last episode. The portability of a layer 2 network that something like NSXT enables, with the WAN routing also software defined, moving or reacting to a DR event becomes that much more easy and simpler, straightforward. Your runbook is multiple bullet points and not multiple pages to get your network back up in the case of a DR event. That seems to be the software defined benefit, in my opinion. A lot of what we talk about is just a new way of doing stuff that we've all kind of been doing. Hopefully it's easier. In my opinion, different is not a virtue, and yet different is sold so often to us as a benefit. It's like, okay, different.
It's the whole new way to do it, right? But at the end of the day, it's still VPN tunnels. It's still...
Is it better?
Right.
Is it better? And that's the judgment. And
I can say it was kind of funny because I was doing Cisco IWAN deployments before Cisco called it IWAN. Because, like I said, IWAN is not a product or a thing. It's protocols that have been around on networking for decades, just bundled together, and building that config out from scratch to have it function like an SD-WAN. The configurations are like a mile long. I couldn't imagine a non-network engineer having to modify that without some form of tools or whatever. So when the SD-WAN came along with vendors such as CloudGenix, Velocloud, Silver Peak, Viptela, it was a blessing in disguise to see that, to make that much more simpler and easier. It's all about working smarter, not harder these days.
Well, I think that's the core of it, right? Is you had to look at that path monitoring. What is this link, this VPN link? How is it behaving? What's the jitter? What's the latency? What is MOS score? I don't know, whatever it is, right? And then write the rules to adjust it and swing traffic based on these criteria. And you had to, as the engineer, define all of that, right? And I know going through the CloudGenix stuff, that's the virtue that they describe, is that they monitor that. They've already done that work, and you just plug it in and have that easy to turn QoS type dial of this application needs to behave this way, so it pays attention and swings traffic, right?
Mm-hmm. Well, you mentioned a few of the solutions we've worked with, Mac. Now, from what I understand, there's not really a VMware as the big gorilla hypervisor where it's standardized and you've got 90% market share. Does something like that really exist in SD-WAN, or is it pretty well balanced in terms of the distribution? Do we have a preferred
amount of players in the SD-WAN space?
Right.
No one's done it and has that market share, right? Yeah.
And a lot of service providers have coined their own SD-WAN. Because obviously,
sure.
They're like, oh, you're turning down my expensive MPLS circuits for cheaper internet. They need to stay in the game, right? So they're deploying their own proprietary SD-WAN offerings.
I scratch my head anytime I hear that. It's like, let me get rid of Comcast to pay Comcast to manage my SD-WAN, right? That's
and not to pick on ISPs, but I'm going to pick on ISPs. I think a lot of the bad feeling is the fact that there is no reason there's no reason monetarily for a company to go to their customer and say, hey, let's renegotiate your contract and get you a cheaper price, right? But then you've got these companies that have historically, oh yeah, I've got a T1, great, and I've got a 5-year contract and I keep renewing it. Well, by that very setup, that arrangement, you're paying for old tech, but at premium rates when it was new, and that kind of renewal cycle just kind of goes. And I almost feel like, and I don't deal with this, so I might be wrong. It's definitely wrong in some areas, but that might be one of those contracts that just gets kind of rubber stamped year after year and forgotten about, and then someone looks at it and says, "Holy crap! I'm paying that for 1.5 megasecond. What?" And yeah, that was a price 15 years ago, but they're not going to tell you that you guys can cut over and get something cheaper or newer. And I think that's driven a lot of this.
When I work for the Cobalt Group, we never signed contracts on circuits more than 36 months. 3 years was the max, just because the technology would change so fast.
And that's still a long time.
It is.
Yeah. Especially back in the days of 56K or ATM or a free relay or the T1, even T3. But it is fascinating to me that people talk about the SLA. Because ultimately, if your circuit goes down and it is that important, it's important to your business, no question. But as a home user, it's almost funny when you think about how good our home internet can be. Now, would you bet your life on it? That's the question you have to ask yourself. But I mean, as long as you've got 2 ISPs, in my opinion, cheap internet ISPs, and they're not coming into your building on the same fiber, so one backhoe can take them both out. Mm-hmm. And that is also challenging. That might probably not the case unless you make it so. I like the idea of going to cheap, high bandwidth links. If you can if you have the option, you can look in to say, well, they've got different backbones. So even if a common provider, a tier 1 provider goes down, you're still protected against it. You might have some good savings off your dedicated circuits going that way, and then plugging something like SD-WAN in, or at least better resiliency and better performance, right? Yeah, even if cost is a wash, your bandwidth might go through the roof at that point.
Bandwidth and performance, and like I said, access to the cloud, and some security enhancements are all benefits of SD-WAN. Absolutely.
I guess so. Is that concept that to do to do SD-WAN, you need to have multiple circuits at your branch or wherever. Is that a hard requirement, or is there enough benefit out of doing SD-WAN to say, hey, you know what, I'm going to switch this, even though 2/3 of my sites only have one provider that I can get in there that's realistically reasonable or resilient or whatnot. I don't have a second option for internet at these sites, right?
You don't need dual circuits. Obviously, that's usually a business decision with SD-WAN. Actually, which really with any wide area network in general, but the SD-WAN specific, you don't need multiple circuits. Most often with customers with branch offices, you end up tiering them tier 1, 2, and 3. Where like tier 1, is going to be your head ends, is going to be mission critical. Tier 2s are more larger sites, maybe they're redundant, and then tier 3s might be single point of failure on the circuits.
It's like if you're a bank, it's not as big of a deal if the bank in Safeway goes down, but that big branch in downtown Seattle is that kind of a thing, that kind of a decision. Yeah.
It could also be something like, you have a primary circuit, your internet, maybe your backup is an LTE wireless connection, right?
And do some traffic shaping on that and just let
that way
transactions happen or whatever.
The LTE circuit doesn't get used until there's a failure of the primary circuit. Makes the failover easy and lets let SD-WAN handle all that.
I've thought about doing that at my house.
The
LTE modem.
Honestly, I've got the Meraki kit sitting here, and I've paid the $20 a month for that LTE modem, and
that's my beef. And I know we're talking about $20 a month, but still,
I've used it like in the last couple of years, maybe a total of a day, like actual use on it.
But it's insurance, right?
Yeah,
it is insurance.
But my Zoom call's still gonna suck.
Do you have LTE out where you are?
Where I am, yeah.
Yeah.
I mean, and even at that point, right, I can turn on my hotspot and just connect my laptop to my hotspot. So I don't know if it's worthwhile for the house, for the you and the eyes Yeti.
Yeah. I was thinking about cheaping out really and just doing like the hotspot on the phone and then having a wireless router bridge to it and then have that sit on my network as an endpoint and then just switch my route over should things go poof. And I'm cheap.
You get one of these for $100 and.
Another $100 Cozzo piece of kit that just is miraculous and the greatest thing ever. Look what I found.
Hey man, I use it when I travel. That comes with me, and that's my hotel internet. That's my hotel access point.
That's had some longevity. That's good though. That's good.
Yeah. I guess specifically because it's got that built-in Wi-Fi bridge mechanism to it, right? It makes that component easy.
And then that is that leverage WireGuard?
It's got an open VPN component built to it. You can flip the switch and it open VPNs, but it doesn't have a really great security circuit in it, so encrypting all that traffic kind of kills it.
Mac, are you familiar with WireGuard?
Not.
So, and I'm going to give you a real layman explanation because it's just I'm living in user land, not in kernel mode with this conversation, but from what I understand, it is a modern VPN client structure. So it basically is an alternative to IPsec or OpenVPN or whatever, IP or L2TP. But the thing was, so I have, Cozzo and I have our little data center rack that we play around in, and we have Merakis, and I have Meraki at home. And that Meraki, the MX64 is what's encrypted traffic capped at Cozzo like? Do you get the full 250 meg on that, or is it less than that?
I feel like it. I know I've specifically called out Plex as a something that needs to go over the internet and be HTTPS and not over the tunnel, because it makes a difference.
I think that'll push a gig unencrypted, out to the internet fine, both bidirectional, and I think encrypted it'll cap at 250. So, like we were talking about earlier, once you start to get into that multi-hundreds of megabytes creeping towards a gig, encrypted pass-through, you're talking about some heavy-duty hardware, or at least specialized hardware. WireGuard, I can do full line rate 1 gig point-to-point over the encrypted tunnel with a couple of small Linux VMs, one on each side. And it's just, from what I understand, it's very It works, but I guess it's very immature, certainly relatively immature, and it's use at your own risk kind of thing at this point. But it's I wouldn't say it's easy to set up. A lot of people say, oh, it's super easy. There's some command line or there's some file config you have to do, but overall, it's a very interesting concept, and it kind of gets around the whole. I can only like I have Ubiquity right at home, Unify, and the 40 megabit a second encrypted bandwidth that I can get through that thing. Might as well just walk it over there.
Everything, every firewall ever has got like I want to encrypt some traffic. Well, cut off your leg.
Yeah, yeah. Everyone's running that like old Celeron from 13 years ago, and their firewall.
Celery processor. I haven't heard about those in a minute.
Yep. Exactly. Well, do you have a go-to for SD-WAN, Mac, or is it definitely it depends? Our favorite kind of
depends on the customer requirements. Yeah, like I said, CloudGenix, Velocloud, Silver Peak are all great solutions. Viptela, I'm kind of on the fence on. If you had an on-prem requirement and you need SD-WAN, Viptela would fit that bill, where CloudGenix, Velocloud, and Silver Peak require you to have connections to the cloud to function. Meraki is always a good solution, based on the size of the company and stuff, but their dashboard's really easy to work with. And then Palo Alto, obviously, which recently Palo Alto acquired CloudGenix. So CloudGenix and Palo Alto, same company now. Viptela obviously was acquired by Cisco, so that's why IWAN was deprecated for Viptela. And then Velocloud was purchased by VMware, right? So
you're starting to see those little circles get absorbed into bigger circles.
Right.
Was why when that acquisition happened, it was a couple of years ago. I was like, why would VMware does virtualization care about SD-WAN? And the reason for their Velocloud acquisition was, if you're going to move your workloads, your virtual workloads to the cloud, VMware needs a way to get close to the cloud, and Velocloud, as an SD-WAN solution, provides that pathway to bring the cloud closest to the end users.
I'm having a lot of conversations about VMware Cloud on AWS or Azure. It's coming up an awful lot.
It is.
It's interesting. I remember vCloud ARE from a few years ago, right? And I feel like VMware, if they had stuck with that or had a bit of a stronger organization around that, they might be up alongside AWS and Azure in terms of considered the same hyperscaler kind of thing. Oh, I can just vMotion my stuff
as a provider
up
type.
there.
Yeah.
Yeah, I feel like they had it, and it was just mismanaged for whatever reason. So now they're kind of having to get on the train a little bit late. But I mean, boy, talk about full steam ahead. That's all I'm hearing about lately is that. So it seems like it's gained quite a bit of steam, which is good, because that's the thing about hyperscalers is a lot of times the cloud is a billion things, right? But one of the things, and no matter how much you can say that's probably not the most economical use of the cloud, is can I run my VMs up there? Yes. But right now, without VMware Cloud, yes, but you have to convert your VMs. Even if you run Hyper-V on premise, it's not going to run natively in Azure, which in my opinion is a crazy misstep by Microsoft. But that's really not the idea of the cloud, is running your VMs, even though they allow you to do it, right?
Yeah. And that conversion takes time. I guess that's the big one, right? Yeah.
It does. It's a huge barrier to entry if all you're looking to do is lift and shift. Huge barrier to entry.
And with that plus the cost of it, right? Running a native SQL as a service versus here's my SQL server as a VM. There's two totally different pricings.
But then there's all kinds. I know we're getting off to the side here, but then there's all kinds of cost acquisition on ramps to that too, like refactoring your applications to leverage a SQL native instance. You want to rewrite your app and spend thousands of man hours? Yeah, okay, that's not free.
Right.
Things like that.
Yeah.
But I mean, even if you convert to Azure or convert to an AWS native VM, and then you want to, let's say I want to use my site for a DR for that. No, like you still have that conversion point. So I think that's why VMware Cloud, it's something that I think there's been more demand than supply for it for a long time. And I think supply is finally catching up with VMware on that, which is good. Well,
nice.
Cool. Mac, it's been awesome having you on. It's been a lot too long. I think it should be shorter next time before you have you back on. Is there going to be any Cisco Live coming up here soon? Any chance of that?
I think it's virtual again this year.
Yeah. Yeah, we'll have to have you on after that.
Yeah, there's one other thing I wanted to talk about on SD-WAN. Never seen that before.
Oh.
So I was looking at that. So Velocloud actually has a feature that I had never seen before. So as a network engineer, it's what I've done most of my career. Whenever we go to load balance data across several circuits, on routers, you can actually do per packet or per flow. A flow being a conversation, right? So let's say you had two 1 gig circuits that went to the same place. If you do per packet load balancing, what if the packets arrive at the other end out of order? That breaks a lot of applications. So rarely do we ever do that. It's always per flow load balancing because that's safer and it works, which means if you have one conversation and two circuits, that one conversation rides one circuit, right? If you had two conversations and one could go on each circuit, right, to balance that way, and then you extrapolate that and say, what if there was 500 conversations? Right? One conversation can require more bandwidth than another, but you're not balancing on the consumption, you're balancing on the number of flows, right? So it's always been kind of a limitation. So with SD-WAN trying to make things better, Velocloud's got a feature which is kind of like RAID 1 for storage. You select what your mission critical apps are, and it'll send the same data down both circuits, and whichever packet gets to the other end first, it'll take. So if you have, an area that has spotty coverage, or you're always having, circuit problems, maybe some CRC errors or something like that, it's quite possible that Velocloud's RAID 1 feature will improve that immensely and improve your experience for applications such as Zoom or any other kind of video conferencing, just because it's going to send that mission critical data down both paths and grab whichever one makes it to the other side first. So therefore, it's actually a per packet load balance with redundancy. I thought that was actually pretty cool.
That is very cool.
Nice.
Yeah. And thanks for using one of our features of the episode that we neglect so often. So that's cool. All right. Well, Mac, thanks again for joining us. Awesome to have you on. Looking forward to the next time we can have you on for some chat, network stuff. Yeah. So before we wrap, a couple of announcements. The aforementioned from the last episode, if you missed that, we have a virtual workshop coming up, the what and the how of microsegmentation with our very own Matt Cozzolino. Yes, the workshop date is Thursday, April 16th, so it's probably coming up soon if you're listening to this episode, from 1 to 3 in the afternoon Pacific time. The URL is super long, so just check the show notes, register online, there's a link there. And the big one, we now have open enrollment for Matt's class, his very first class coming up, Intro to Microsegmentation using NSXT. Really hot topic, we've got a lot of
Come show up, let's learn about it.
Yep, those class dates are May 25th to the 28th, so end of May. But enrollment's open now, and here's the real sweetener here. If you enroll on the site, which is the link is in the notes, as a special thank you to all y'all who listen to the podcast, if you enter the promo code PODCASTPODS, podcast singular, pods plural, podcast pods, when you enroll it, you will shave $1,000 off the price, and we'll kick in a pair of Apple AirPod Pros. So that's nice. Like I said, I'm gonna get the old dust off the old fake ID and sign up, I think. Yeah, so the promo codes, they're limited though, the rub, first 10 people to claim them. So if you haven't registered yet, get your approval from your manager, get registered, and get ready for class. So again, Mac, thank you. Matt, thank you.
Of course,
thanks. Those two. Yes. Thanks for listening to Data Center Therapy, y'all. Have a great day.